A&M Bozlur Rahman, that's his full name. He is a senior software engineer at Contrast Security and a respected Java champion. He has over 10 years of experience in the software industry, primarily in Java and Java-related technologies. Outside of work, Bozlur enjoys mentoring, writing, speaking at conferences, and contributing to open source projects. Bozlur is the founder and current moderator of the Bangladesh Java user group. He was named the most valuable blogger at DZone, one of the world's most well-known technology publishers. And besides DZone, he is also the editor for JavaQ at InfoQ and an editor at Fuji.io, a site for OpenJDK enthusiasts. And this one's pretty interesting. Bozlur has written 4 books in Bengali about the Java programming language, and all of them were like bestsellers in Bangladesh. Bozlur Rahman has a widely followed Twitter profile. You could follow him at BAZLUR_RAHMAN, Bozlur_Rahman at Twitter. On today's topic, we all know as programmers, multi-threading is very important given the performance demands from today's applications. But we also know that threading and concurrency are concepts that strike fear in the heart of a rookie programmer, right? So they could unleash chaos if they're not done right. And then most people are like really wary about implementing multi-threading and their projects. Project Loom sort of makes the whole thing easy. In this session, you'll learn what virtual threads are and how they're implemented and how they solve some of the modern problems and any shortcomings that we should keep in mind when we're implementing them. Project Loom introduces virtual threads, lightweight threads that aim to dramatically reduce the effort of writing, maintaining, and monitoring high throughput concurrent applications. So it's a very, very interesting and important topic that is of use to most programmers. Rahman, thanks for taking the time out and for doing this webinar. Over to you.
Thank you, Shashi, for wonderful introduction. So, is there any way to make it interactive? Like, can I ask questions to audience while I'm delivering the the content?
Absolutely, yes.
Okay, perfect. So I'll be asking some question, not always, just to give an idea of what I'm doing with it. So feel free to respond with those questions that will make this session basically interactive. So I enjoy interacting with the audience while I'm delivering the content. So all right. So without further ado, I'll start. As you see, the title advertised, creating a million virtual threads using Project Loom to improve throughputs. So I'll first start with this million. Million is a huge number, right? It's a large number. But typically, is it possible? Is it really possible to create million threads using Java? That's the line. That's where I'm going to start with. So before going into the talk, I'll start with a small demo. And then, I'll have a couple of demos in this whole session. So I'll showing codes, I'll showing my IDs. So I'm just giving you the idea of what I'm going to do, basically, right? So let me start with my, demo first. All right. So that's a pretty fairly simple class. I'll start, first of all, I'll explain what it is, and then I'll just run it. So first of all, it's a class where we create inside the loop. You see, we have a loop over here. It's an infinite loop, and we'll keep creating threads, and then we'll keep a counter over here in a long header. So that's what I'm going to do. And after creating a certain numbers, I'll stop the program because it will keep running. So that's the idea. And in over here, it's basically prints the number of threads we have created so far. So if I run this program, let me see if I can run this. So I was not able to run this. Okay, so here's the thing. Project Loom is still under preview feature. Preview feature is basically, when JDK is shipped, some of the features are not enabled by default. So they are so that you cannot use them in production. The idea is those people which are to be tested by developers and giving feedback. So the project Loom is still under preview in JDK 19. So you need JDK 19 first of all, and then you have to enable. This is a flag that you need to supply when you want to run this program. So in IntelliJ IDEA, you can do that like this. So if you add this, then you will be able to run this program. So if I run this program, I hope now this is going to run. Okay. So in fact, this is turning. If you can see, the number is pretty staggering. Over here, you see, I have already created 12 million threads. And then it will definitely create more. So it will keep creating. I mean, what I'm going to give you a sense that it's possible actually. I mean, I'm just justifying my title of the talk. So I'll stop here. And now that you have seen that it's possible to create millions of threads using virtual thread, I'll go ahead and set the stage of concurrency first, give you a prior idea of how the classical or traditional threading model is being used, and then I'll go from here. So since I have already introduced, so I'm skipping this slide and then go straight with this agenda of talking. I already already give you some idea what I'm going to do, but in the highlight version, which is I'm going to talk about what is virtual thread and how does it make sense, and if there are any limitations. So you have to keep in mind that the virtual thread, the feature is still in preview still in preview. So it's not out there yet. We'll probably not be able to use it in production right now, but we can play around it. We can get get to know about it, and then when it is shipped in the JDK with the we'll probably able to use it. So, and again, it's going to be a bit high level because concurrency within an hour, it's difficult to explain whole thing. So I'll keep it very short and concise and high level. All right. So a few things. Let's talk about a little bit about the how classical threading in general how Java works basically. So you can say Java is made of threads, right? Because from the day zero, thread was introduced in Java, and that was one of the reasons why Java is popular, like the way it is popular, right? It's been popular, it is popular now. Hopefully, it will be popular in next decades. And threads and concurrency model is definitely one of the reasons why it's popular, like I just said. So. And what is basically threads means in Java? So thread basically is give you an execution environment in Java. The idea is you have a bunch of code, and let's say you have a few lines of code, and these codes are going to execute by an environment, and threads is that environment in Java. And if you have multiple threads, that means you have more execution environment. And when you have more execution environment, if they can, run simultaneously, that means you can do things simultaneously. That's the whole idea, basically. So in a Java program, you will have multiple threads, and that means you will have multiple, execution environment, and your program will do multiple things simultaneously. And that's why we need, sometimes we need to write program in a way so that we can achieve that goal and we can get benefited. So it definitely gives us it definitely gives us a what do we say? Strong tools and opportunity to make our program responsive, serve more users. So many there are the benefits are in a lot, basically, but again it also brings some baggage as well. That's why programming concurrency is difficult. So I'll get into that. So let me go into the next slide. Like I said, Java is made of threads, and there are all sort of places where we interact as a developer with Java threads. For example, this is a main program, right? And we started with the curly brace over here. Sorry. We started with the curly brace in the main method, right? And then we ended over here. So this is a good block. We have one line over here, but this one line is going to be executed by a threads internally. And if you see over here, if you keep set a breakpoint and take a thread dump, you'll be able to see that this is running by a main thread over here. And there are other places, for example, exceptions. If we want to deal with exceptions, we get them from the threads, because thread maintain the stack trace, right? There are other things called thread lookouts, debugger, profiler. All of them deals with threads. So that's why be a well-grounded developer, we definitely need to know a lot about concurrency in general, threads, at least high level. If we as a developer, sometimes we don't write concurrency code directly, rather we use tools, other frameworks, libraries, but at least we need to know at least a certain level that these are the things available, and these are the way things can go wrong. So to be a proficient Java developer, definitely we need some sort of knowledge. So that's why this talk makes sense. In fact, even though Loom is not there out to use in production environment, but it will eventually, right? The idea is Project Loom will probably be the de facto standard way of concurrency in future. So we have to get used to it. We have to know every early. So that's why these talks in fact make sense. All right. So let me go into the next slide. Let's see what I have. Okay. So now that I have established the fact that we need to know a little bit about concurrency in general as a Java developer, let's see how we do create threads traditionally. When I would say traditionally, it means pre Java 19. That means we are not using virtual thread yet. So that's the traditional or classical threading model of Java. For example, if we want to create a thread, what we just do thread. There is a class available in Java lang package, which is thread, and we can create thread directly using the new operator, and then we can provide a runnable, or we can definitely do lambda expression now. Since Java it introduced lambda expressions, and it's easier, and then you will get an instance and you can call thread.start. That's it. So this runnable or this lambda expression, whatever we provided to this constructor, is going to be executed by a thread, which is this new thread. So that's what we do in classical environment. Even though if we use high level API, for example, if we let's say if we want to use executors internally, this is what this is how we create threads. So all right, so now we have to keep a few things in mind, which is Java thread is not really a Java construct, rather than it's a thin layer of operating system threads. So Java basically requests there is a kernel call, there is a native call. Basically, when we create Java threads, OS gives us a thread, and all the execution happens basically by by OS, and OS maintains the scheduling, right? So we have to keep that in mind. Although we have a classic class Java class, we have a Java construct, but it's a thin layer. So it's a 1.1.0.1 mapping with the operating system thread. So we have to keep that in mind. All right. Moving on. Now that we have established that threads are this is how we create threads traditionally, and Java threads are not Java construct, rather than it's an OS construct. Creating threads is pretty expensive thing in terms of programming cost. For example, if you create a threads, it requires like 2 bytes of memory outside of the heap. So when we create threads, it takes 2 megabyte of memory, right? And those memories outside of thread. That means if, let's say, if you have a 4 GB of a heap, and if you have an operating system with 8 GB RAM available, that means 4 GB will be allocated for your Java heap, and then if you keep creating threads, those memory will be allocated outside, the other memory available in your operating system. So that's a huge deal, and that means if you want to create a lot of threads, you'll probably run out of memory. For example, if you want to create million threads with the traditional threading model, you need around 2 terabyte of memory. That's a huge memory, right? That's a huge memory that requires outside of our heap. Also, if you have a lot of thread, that doesn't mean you are going to get performance boost, because let's say you have 1,000 threads and then you created 10,000 threads. Constantly you have to switch context, right? Operating system will schedule those threads. So when you have 1,000 threads, the chances of getting opportunity to run certain program is more than when you have more threads, like 1,000 threads, right? 10,000 threads, because operating system, in our computer, like physical computer, will have a certain number of core, right? For example, the current machine that I have, it has 8 core. So let's say I have 100 threads. That means these 100 threads will be distributed by the scheduler, operating system scheduler, to this 8 core. So at a point of time, 1 core will run 1 threads. So there are certain scheduler available. For example, it could be round robin. So if it is a round robin, every thread will get certain time to be executed. So and then context switch also takes some time. For example, 100 microsecond over here, but it seems less, but when you have so many, context switching, too many context switching, it adds up. So that's why, it is considered expensive operation. Creating too many threads is definitely expensive. When all this aspect, you add those aspects to it. All right. So now questions get to be, so now that we say we have a, creating a lot of threads is expensive, but if we want to do it, we can do a certain number of it. But then after a certain threshold, we cannot do any more. However, let's give you an example, concrete example. Let's say we have a web applications, and web application basically can't interact with the client, right? And we want that's how web application is done and served. So think about it. If a web application continuously, concurrently or simultaneously serve 100 users, and then another web application that can serve like 1,000 users, which one is better? Definitely the one that can serve more users. So traditionally, in Java application, what happens is when a client gets a request, so with the web applications has a pool of threads, let's say 400. It depends. It's definitely tunable. But let's say it has a pool of threads. So when a request comes, the web server, what it does is it gives this responsibility to interact with this user or serve this users to a thread. So let's say I have a 400 threads at a time, in a pool. That means at a point of time, I'll be able to serve 400 users. That means my throughput is, let's say, 400. If we have more threads, that means I'll have more throughputs to the application. That makes sense, right? And we don't have limitation in concurrent connection, to be honest, in our modern operating system, because modern operating system pretty much can handle millions of concurrent connections. So that means if we have more connection, more requests to the web server, and if we can handle them, that means we achieve more throughputs, right? That's our goal. The problem is, although we can handle million concurrent connections, we cannot have millions traditional threads, right? Because threads are expensive. And we cannot create as many as we want, like millions of traditional threads is not possible. Like I said, it would require like 2 terabyte, 2 terabyte of memory. That's a huge memory. That's a limitation. So now you can see there are certain problems that we cannot solve using the traditional threading model. Now you can ask me how many threads in fact we can create in reality with the threading model we have and the machines we usually use. So I have done a test on my local machine. This is the machine I'm currently using to present. And this is a simple code that you can even use to count on your machine. For example, you just copy this code and try and run it. You'll be able to see how many threads you can create on your local machine. So this is the number of thread I was able to create with this machine. I have a 64 GB of memory, so it's a good memory for a operating system. And I was able to create like 16,000 threads. And after that, the program crashed and I got this error, which is out of memory error, right? So this program will run for a while and then it will crash. And in the exceptions, it will be able to know the number, how many threads you were able to create. So that's how you can really count. And the number is not really a lot. I mean, if you have more memory, you'll probably able to create a lot of threads. But then if you have like 8 GB of memory, you will not be able to go far. So that means, you see, we are limited by the number of threads we are able to create. Since we are limited by the number of threads, that means even we try a lot, we will probably not be able to achieve high throughputs with the traditional threading model. Of course, there are other ways. I'm not going to discuss that topics, but just I'm trying to stay on this traditional way of dealing things. All right. So let me proceed. I'll have a demo over here. So let's see if I can show you the demo. It's an idea of let me see, single thread server. Okay. All right. So the demo is pretty much. I'll not probably run this program, but let me explain this. So what this program is done is basically it's mimic the web application servers that we use. For example, it can be Tomcat, it can be web logic or other application servers we have. So basically, it's a mimic those very high level and very basics. So what happens is it creates a server socket with the 808 port and then waits for a client. And when we get a client, it just handles, right? And over here, I don't have a lot of code. It basically, how would I run it? Let's see if I can run it. Okay, so I was able to run. And if I telnet, so if I telnet over here, so what it says is, I've got one server, and then I can start typing here. For example, hello. So I'll get, from this server, I'll get a response which is uppercase. So that's what it does basically. Whatever you write over here, it ping back with the uppercase letter. So if I write Starof, it will just, send me a result Starof. So now the question gets to be, now it's serving a particular client, particular user. What if I want to, connect another telnet user. So if I do that, if I keep writing over here, it will not. I'll not be able to. You can see it's not responding. Even if I keep writing, it will not. It will not respond. It will not respond. So now, if I, kill this terminal, let me kill this terminal, and then you can see immediately I see a lot of results, right? So the reason is this web server is pretty much single-threaded. It can handle only one user at a time. That's not super useful. So what we can do is we can turn this, applications into a multi-threaded web applications. How? We can just create a new thread whenever we get a current connection. So thread t new thread, and we can pass a lambda expression over here. So this lambda expression basically will call this handle method, right? So since it throws in our exceptions, what I can do is let me use this catch exceptions. New. Okay. So what I have done is basically whenever I have got a client request from a client or connections, I'll just create a new thread and give that thread to handle that connection. So start. That's it. So if I run this program now, I'll definitely able to run multiple. This program will be able to start multiple client at a time. So this is what I have been saying. So this is how web applications works. That means the amount of client it can serve is limited by the number of threads available over here, right? So if we keep creating, every time there will be a new request, it will create a new thread, and the client will be served by that thread. The problem gets to be after a certain time. I have a program over here. This is a it's just to demonstrate, which is it's a sort of DDoS attack. What I have done over here is I'm going to create like 20,000 sockets, and I want to connect this 20,000 socket with this this server that I have just converted into multi-threaded web server. And if I run this program, I'm not going to run it because there is a chance that this program can crash, and it may interfere with the slides. All right. So okay, I've got some questions. All right. I'll try to get. Okay, I'll definitely try to go slowly. Okay. All right. So over here, so if I run this program, what it would happen is, it will keep sending requests to this single-threaded server, and since we have like 20,000 sockets over here, that means to handle these 20,000 sockets, I need 20,000 threads over here, which is not possible, right? Because we established the fact that threads are limited, the OS threads are limited, and it's bound by the memory limitation we have, and it's an expensive operation. You cannot have as many as we want. So if we have that many requests in our web application server, we cannot handle we cannot handle that many requests at a time. So that's a limitation. And this limitation can be solved by one trick, which is if we just instead of creating traditional thread, if we create a virtual thread. How we can do something like that. Thread dot start virtual thread. Now so I have just changed one line so far, nothing else. Now this program will be able to handle 20,000 users at a time. Is it a magic? It soon sounds like magic, but I'll get into how virtual thread works and how we can how it is done internally. But the change in terms of our traditional threading model to a virtual threading model it's that simple. Pretty much, traditionally we used to create a thread using thread t new thread, something like that, right? And we're not going to do that for virtual thread. We'll just call thread.start virtual thread. That's it. And that's the difference. That's the only amount of code you have to write. If you want to do same thing that you used to do with traditional threading threads. Now you can do the same thing with the virtual thread. All right. So that was the demo. Moving on. I mean, similar things. So if you want to, I have all these slides available, all this code and slides available on my GitHub repository. So I'll share my GitHub repository, all of you, after after we have, after this talk. So don't worry, you'll be able to use and try out all of this. All right. So let me, so I have just shared all these codes in this slide, so I'm skipping. All right. So now that initially I have started, like, I demonstrated you that we can create million threads, and then, and our problems, which is throughput, can be mitigated with this million if we have too many threads. Now that we can create, the idea is how how does that happen? So there is a thing called Project Loom, and this Project Loom is being actively developed for many years, and it is still being developed. I mean, we don't have the final version yet. It is still being developed. Developers like you are, trying it out and giving feedbacks. So based on those feedbacks, if there is an issue, they're correcting it. So it's a high time. If you want to try out, and if you see any problem, if you feel there is a thing need to improve, you can definitely send them your feedback. So that way you contribute not only as a user of Java, but also by being a contributor to the Java itself. So that's a great opportunity. If you want to do that, definitely do. All right. Okay. So let me see if there are a few questions over here. If I can see, if I can answer. Okay. So someone asked if I can, speak in Hindi. Unfortunately, I can speak only two languages, which is one is Bangla and another is English. I can understand a bit of Hindi, but I'm not good at speaking. So I'm sorry about that. So, okay.
I think, yeah, so none of them are like, none of them are like, yeah, important. I think this one around sockets.
Okay.
It's not very clear.
So what socket do you start? Okay. The question is, I mean, you can definitely look into the socket API, but let me give you an highlights, which is, you can think of a client, what you do basically on a you go to the web application, you type something on a browser, and then when you type something on a browser, what happens? Basically, you send a request to a particular server that's remotely placed, right? So think about that. In that remote server, they're running a web socket. So basically, web socket, you can think server socket. So server socket, you can think of a server, and you are the client. Socket is like your client, basically the client that interact with the web server, right? So that's the basic extreme high level definition. But you can it's a pretty basic API available for since I don't know when, but it's available for many years. I would say at least decades. So just just do a Google, because I mean I could go into socket, but then you'll miss other things that I am prepared for today. So all right. So let me focus on this topic. Okay, so Project Loom, right? So what it does basically, it allows us to create millions of cheap, lightweight virtual thread. When we say cheap, that means like I said in the earlier slides, the traditional threads are expensive, right? It's not easy to create. It takes effort, it takes memory, context which requires what do we say, certain amount of time, and the virtual thread is basically opposite of that. It's a cheap, that means you can create easily. It's a lightweight, that means it doesn't take a lot of memory. The amount, I mean, that way the traditional threads takes. All right. So now that we have two kinds of threads in the JDK, which is virtual thread and the other one is traditional thread, we can divide threads into two groups basically. One is the traditional threads, which is, you can call them platform thread, career thread, native thread, basically the real thread we have so far in our Java ecosystem, right? That way. And the other kind of thread, which is virtual thread, which is, or you can call them user thread. So then keep that in mind. These are the two kind of threads available now. One, I'll keep using different words, but think about virtual thread is a one kind of thread, and other threads are basically platform. You can call them with multiple names: platform thread, career thread, native thread, whatever. Traditional thread, classical threads. There are many names. Okay, so let's moving on. All right. So creating virtual thread is pretty easy. Let me go into the demo immediately. That will make life easier. I will love to interact with the IDE. So forget this code that I was playing. I'm gonna remove those. All right. So creating virtual thread is pretty easy. You can just do thread start virtual thread. That's it. If you pass a new runnable like this, and whatever code you put over here is going to be run by the virtual thread. So if I over here, if I put a print statement, let's say hello world. Excuse me. Just think. This hello world will be executed by this virtual thread, new virtual thread. Okay, so if we want to even know get to know, let's see which thread it's basically run by. So we can do that this method, thread.current thread. Now we'll definitely get an instance of this thread, right? When we create a start dot, you call this method. It's a reference, right? And since runnable is a functional interface, we can replace it with the Lambda expression like that. It's become online now, right? Okay. Okay. So if I run this now, let's see if I can even run it. Okay, looks like I can run it. So as you can see, first line, it printed hello world, and second line, it says it's a virtual thread because we printed the current thread, which is the thread is running this block of code. So this is how we can create virtual thread. There is another way of creating virtual thread, which is over here. What it happens is this method, when we want to create a virtual thread and run immediately, we call this start virtual thread. But if we want to wait, for example, let's say we want to just create first and then we'll run later, we can use this factory method, thread dot of virtual, and there is a method called unstarted. So unstarted method, if you use that, and similarly, you can pass a lambda expression over here. And then you will get an unstarted thread. So this unstarted thread, definitely you have to call, since it's not started yet, you have to call start, to start this thread. But this one is already this one is already started. So if you call start again, you will get an exceptions. So that's a two way of creating a virtual thread. Since we have now a nice factory method, it makes sense to have similar factory method for classical thread as well. So you can create classical or traditional threads using similar approach, similar factory method, which is thread.off-platform. You can there's multiple ways of creating. You can create unstarted thread, you can create daemon threads, whatever approach you want to take. So these are nice addition of API in the JDK 19. So you can use whatever you want. If you want to still like the thread, party new thread, you can use constructor again. Use like this. That's also available. But if you want to use the factory method, that's also available. So it's up to you which way you would like to use. All right. So the only thing is you cannot create virtual thread with the traditional constructor. That's the limitation. If you want to create virtual thread, you must have to use this two approach. And there is another one, which is sometimes what happens is we use executors, right? We don't create threads directly, rather than we create a thread pool within executors. For example, a new fixed thread pool, right? So after that, in our production code, you'll definitely see some code like that. We have executors, and then you pass task to that. For example, using submit. So what you do is submit is basically takes two kind of task. One is either runnable and another is callable. If you want to get something out of this task, then you will use callable. Otherwise, you use runnable. So over here, let's use runnable. And these are the kind of code available in your production environment, or I'm sure you have seen this. So you can also convert into lambda expression this way. So if you want to if you have this kind of code and you want to turn them into this one, definitely use the traditional threading model, right? So if you want to turn them, so if you want to use them, use those code that are being used by traditional executors like this, and you want them to use virtual thread, you can just change one line over here, which is new virtual thread per executors. That's the only line you need to change, and rest of the code could remain the same. So that was one of the goal of this API design, so that you don't have to change a lot, but again you can achieve the same result. You can achieve the better result, which is higher throughput. So these are the ways you can create virtual threads. All right. All right. Okay. So one thing you have to keep in mind is it's still in preview version. It's still available as a preview feature. So if you want to use or run, you have to set a flag. For example, if you want to compile, with JDK 19, that has a code of virtual thread, you have to add this additional flag, which is while you are going to compile them, right? And if you want to run them again, you have to add in this flag, which is Java dot dash dash enable preview, and then the name of the class. And so these are the ways you can do shell using shell, JShell that's available. So that's also uh, uh, using JShell you can also write code. I mean experiment with the virtual threads. All right. So now the question gets to be how virtual threads works. I'll go over quickly. There's two things we need to know internally, which one is continuation, another is scheduler. So have you heard of fork join pull? Let me know in the comment if you know what is fork join pull. Otherwise, I'll give a 1-minute rundown of it. All right. So let me go into the IDE again. Just comment and let me know if you know fork join pull. Okay. Let me see. I have a demo over here. Okay. So that's the demo. Let me see if I can. Okay. So think about this. Just give a read of this code. I'm gonna explain it. So over here, it's a main method, and there is a new class called continuation scope. Don't worry about it. And there is another class over here which is continuation, and it takes a lambda expression which can be again replaced by runnable. I prefer to use lambda expression. That's why all of the place I have instead of writing runnable, I'm using lambda expression. That's the recommended way. So just focus on this 3 line. One is basically first line. What I'm doing is I'm doing it. I have a print statement over here, and there is an interesting method called continuation.yeld, which is with text and scope over here, and then over here there is another line which is another print statement. Okay, so that's it. And in this line over here, I have a new line. It's a print statement, and then I call continuation.run, and then I have another print statement. I have here continuation.run, and then I have another print statement. So the question is, if I run this program, if I run this program, what would be the output? Can you guess, any of you? So this question goes to the audience. Let me see. Just think about what could be the if we run this program, what would be the output? Okay, I'll give 20 seconds to answer. Let me run it. Let's see if I can run it. Okay, so I was not able to run it. The reason is, okay, here's a few things. This is the internal API. It's available in jdk.internal.vm. So that means we are not supposed to, we are not supposed to use them, this API. It's supposed to be used internally. For the demonstration purpose, I just, wanted to show you. So that's why I, use this example. But ideally, in our daily programming, day-to-day programming, we are never going to use them, and we are not supposed to, know about them as well. I mean, because it's an internal API. But for the demonstration purpose, I just wanted to show you. Okay, So I've got one answer, which is C1, C2, start, and then thread, an error. Okay, let me run this. I'll explain after running it, if I can run, of course. So you can see it did something interesting. It's clear it printed start, that means this line, and then it prints this line, which is C1, and then it ran this line, which is come back. That means after executing this line, continuation.yelp, it didn't execute this line, which is C2, but it ran C2 later when I call this continuation.run, and then we're done, right? So if I want to debug it, let's say, I'm not sure if I would be able to debug it, but I can try. Let me see if I can debug it. So that means when I call this method, it goes over. Okay, so it's in the first line. Okay, let me resume program. You see, it immediately started over here. And then if I click on it, it goes to next line, which is continuation.run. And if I resume this program again, it goes over here, which is C1. And if we resume program again, the executions goes away from this line. It doesn't continue with this C2 line. And it directly comes over here. And if we click over there, it calls the continuation.run again. And if I resume this program, you see it started immediately over here. It didn't start from the top. So that's an amazing API that's internally we have in JDK. So what happens is this has been used inside the virtual thread. So what happens is, let's say, let me give you a story. So let's say you have a microservice, right? And you need to accumulate or aggregate some information based on multiple service call. You have to call other microservices. Let's say you have to call 10 microservices. So you can run this code, traditionally, sequentially. You'll call the first one. When you get a result, you'll call the next one, and so forth. So let's say first one takes like 20 milliseconds. So if you want to call serially, 10 of them, so you have to multiply the number. So it will take like 200 milliseconds into 10. So that's the amount of time you need. What if you want to, let's say, send the request asynchronously, and you can send them using 10 thread, right? So now that you send all these requests asynchronously, you submit those tests to a thread pool, and let's say thread pool has a 10 threads, and so basically all these 10 requests will be sent simultaneously, right? So ideally, if all of them can run simultaneously, since they are doing simultaneously, you will get result in 20 milliseconds. So you don't need you need to add up all those time, right? So that's an achievement. That's a great achievement. The problem is, let's say, when you send a request through a thread to a third-party service, and you are making a network call, and network call takes some time, right? It's not a competition at all at this time. It's basically IO. So you send a request to a server which is remotely, and you wait for this result. While you're waiting, your threads are not doing anything. Basically, it's waiting for the result. But threads is expensive resources, like we said earlier, right? And most of the time, it's just basically waiting. So now they think about a web application. When we interact with the server, there is a lot of IO happens. I send a request, I click a button, and then I send a request, and this request is served by a thread in the web server. And so when a lot of IO happens, what happens is threads are basically most of the time stay idle. They don't do anything. They just wait for the result, and then when result arrive, they just uh, serve that request basically. So that's a problem with current traditional threads. Even though we cannot have a lot, and again our threads most of the time stay idle. So it's an expensive thing, and we should not use an expensive thing in this manner. We should utilize them as much as we want. So if they stay idle most of the time, it's a waste, right? What if while they are waiting on a result from a third party service, it can serve other things, and when we get the result, uh, we'll notify the thread that we have got a result, and use this result to whatever the purpose was initially. So we can do that. For example, that's what happens with the reactive programming style. So what they have a limited amount of thread, let's say 10, and all of those threads can continuously keep running, and they are not idle because let's say there is a network call, they send a call and immediately they wait for a call back. So thread, meanwhile, while they are waiting, they can do other things. Similarly, in the virtual thread, what happens is there will be some dedicated threads we call carrier threads. Inside a fork join pool. Fork join pool is basically a thread pool. You can call them thread pool because they have a bunch of threads inside, always running, and those thread basically runs the virtual thread. Now, let's say we have a virtual thread running on a carrier thread, and there is a network call. So what would happen is over here you can see using this continuation, we can pause the execution at a certain point of time. Over here in this example, it executed the line 12, and then it paused or suspend this execution to line 14, and then after a while it resumed the execution directly from line 16, not from the 12 or 13. It started from the where it left. So that's an interesting area, right? So what happens is in virtual thread can yield itself. It means it can be suspended. So when it's running on a carrier thread, there is a network call, and that means that's indicate that network call is going to take some time. So while I'm going to take some time, this carrier thread doesn't need to wait on this network call. Rather, the virtual thread itself gets suspended, so it goes away from this carrier thread. Rather than it gives an opportunity to execute another virtual thread. So you can think of a virtual thread is a Java construct or Java class, Java object, that if it's obviously an execution environment. You put some code into it, and when there is a network call or IO operation, when there is the opportunity to being idle, it suspends itself and it goes away. So the carrier thread now free, and it serves other threads or other virtual thread. It executes other virtual thread. That way, we can our fork join pool that is basically execute all these virtual threads. There's a million of them. They're continuously executing virtual threads, and they are not being idle. So we're utilizing the what do we say? We're utilizing the threads in a proper manner. And in there, since virtual thread basically a what do we say, Java construct, Java object, we can create million of them, and they reside in the Java heap. We don't mind. So even though we create millions of them, they are not running. They are not. The million of them are not running simultaneously. Rather than, let's say, I have a carrier thread with 10 threads. 10 classical or platform threads are running continuously. All those virtual threads. And most of them are basically suspended because they're idle. They're waiting for a network call. When the network call will arrive, they'll just get chance to serve them. I have an example over here. Let me give you an example. Let's see if I can find that example over here. Let's see. Okay, so example is like that. Think about a bank with a fixed number of tellers, right? So let's say there is a 5 tellers, and you go to the bank, and you definitely want to do. You have certain requests, and on average, it will take around, let's say, 5 minutes of times. And when serving your request, this particular teller needs to do a certain things. For example, he needs to do a phone call, or he needs to wait for a email, right? Other things, which is dependent, internally of bank. So while doing all those things, you are just waiting over there, and teller is busy, right? So let's say he needs to wait for an email, and what alternative he can do is he can ask you to sit in the chair. So wait for there. When the email is arrived, I'll call you. I'll call you in a way so that I'll serve. Meanwhile, I'm going to serve other users. So that's the improvement, right? So that means the teller is always busy. It's serving more users, more customers, and if there is a waiting, there is a need to wait, they can wait outside. I mean, in the bands or in the chair. So in general, this is what virtual thread does. So when you have an IO operation or networking call like the traditional web application server has, even in a web application, it's all about IO, right? You can send requests and you get served. So it's a lot of IO operations. And when there is a IO operations, there is a lot of waiting. So virtual threads removes the waiting. There is a dedicated threads. We can call them carrier threads. We can call them native threads, whatever threads we name it. So let's stick to a one naming convention, which is carrier threads. And so virtual thread basically get chance to be executed at a certain time, and there is a network call, and then it's suspended until the network call is done. Let's say I'm requesting another web application service, and then when I'm gonna get when our socket will notify me that the result is available, I'll resume again. The virtual thread will be resumed again. So that's the idea. And since it's a Java construct, what do you say? The operating system doesn't know about virtual threads. It's on top of a Java construct, and it run on top of a traditional threads. That's the highlight. So there are multiple benefits on those, which is now threads are cheap. We can have millions of them. That means it definitely improve our throughputs in our application server. Since it's most of our waiting happens in blocking IO and IO operations. So we are utilizing our resources wisely. More, we are creating a lot of virtual thread. That's okay. But they're most of the time they're just in the heap. They're not being executed, so they're not using my resource. They're not using my CPU cycle. So there are a lot of benefits, and now we don't need to use like thread pool and other things. For example, we used to use thread pool, right? Thread pool is there are certain benefits of having thread pools, but again, it also has some certain benefits. For example, to tune them, you have to find a sweet spot. You don't with the virtual thread, you don't have to do any of those. You just you have a task, and you just give that task to virtual thread. It will just gets done. If there is an IO operation that needs to be waiting, it will just wait. So I have a interesting demo for over here that I can show you. which is interesting. Let me show you the demo. So that's the image downloader. So what happens is this is a site, right? This is where I can download random images, and I want to download thousands of them. So I have two way of doing it. One is using thread pool, I mean the traditional way of how we do, and another is virtual thread. And if you run this program, you'll see huge improvement in terms of the time. I mean, the amount of time to takes downloading the thousands of images. Let me explain a little bit. Let's say I have a thread pool of let's say this is a fixed thread pool, like 100 threads, right? Let's say I have 100 threads in the thread pool. Now, when I'm sending requests, I can at a time I can send only 100 of them, right? And 100 threads is occupied. When they are occupied, the thread pool will not be able to take any more requests. All the requests, all the tasks will be in queue. So basically, it's working as a batch. So at a time, it's taking like 100 of them, and when they are finished, it takes another 100. It takes another 100. But most of the time, these threads are basically waiting because it's called a network operation. Until it is response, I get the response. It's just waiting. It just waits. So those are the idle times, and those idle times, the threads are not doing anything. They're just wasting CPU time. And the same thing can be improved highly using virtual thread, because I can send the 1,000 requests at a time. I mean, it's just for loop. I'll just send them immediately, and I'll have 100 of virtual threads, and all of the virtual threads will start immediately. And when one virtual thread start, it see a network operation, it yield itself, it will be suspended. Another virtual thread will come to that place, and it will call a network thread. And since it IO operation, it will yield itself, it will suspend itself, and another virtual thread will take place. So immediately all the virtual thread will start, and then since when there's a response, virtual thread will be resumed again and do the rest of the work. So if we do that, it gets a huge improvement. I have this code in my GitHub repo. If you want to run them, try out, definitely feel free to do that. You'll definitely be able to see the results. So I think we are we are pretty much end of my talk. So let's see if I can take some questions. So I had another things, probably I will not have time for that, but let me go into thank you slides, and I'll take some questions over here. There's one question which is, which version of Java started supporting virtual thread? Okay, so it's from 19. It's still under preview version, so you will not be able to use them in production environment yet. But if you want to play around, try out, if you have a pet project, side project, you can definitely use them and see the result.
Right. Yeah. But thanks a lot, Boslu. Great session, very insightful throughout, and it really, was very, very interesting to see how threading could be brought within the reach of a junior developer as opposed to a senior developer. It's only senior developers who get to talk about threading. But if you create like a safety net as the one that you showed, I think it makes the whole thing very easy and also inexpensive. So thanks a lot for taking us through this, through the project Loom. You could see the links online, for all future updates, just to keep in touch with what's happening in the world of Java. Do follow Boslu Rahman, BAZLUR_RAHMAN. So it's there on the thing. And also in terms of the resources, we will have the deck, sent out to all the participants. So that you could, so these resources that you see right now on the screen, on where you could actually find more resources to learn new stuff. So thanks a lot, everyone, for joining us.
Thank you.
Thanks a
Let me
lot,
share my.
for taking it. Yeah.
Sure.
Go ahead.
Just give me. Let me share my GitHub link where all these codes are available, so that you can, if you want to try them out, you can definitely try them out. Just give me a second.
Yeah.
Okay, so I'm pasting it in the chat so that if you want to, I have slides and codes also available in this repository. So if you want to try out. So thanks all of you for attending these sessions, and I always love to talk about things also. I'm excited about. So I'm very excited about Project Loom, and I hope you are all as well. Thank you, everyone.
Absolutely. Thanks a lot, Bozlur, and we hope to get you back soon for another session.
Hopefully.
Yeah. Thank you.
I would love to.
Bye.
Thank you. Bye-bye.